Hey guys, hi again. Okay, today we're gonna talk about basically graphs of motion over here. We're gonna talk about two types of graphs: distance time graph as well as speed time graphs. Okay, let's just start off with a distance time graph. Before I start off, let me just show you a simulation about this. Okay, let's start off with this guy here. Okay, as you can see, this is actually a position time graph, but for the purpose of this simulation, we can consider this to be a distance time graph. Okay, the first thing you notice about this guy is standing here at 5 meters. So as he's standing here at 5 meters, as the time goes by, what happens? He's still always at 5 meters. In other words, let's just start it off again. Okay, at 0 seconds, it's at 5 meters. 1 second, 5 meters. 2 seconds, 3 seconds, 4 seconds, is still at 5 meters. 5, 6, 7, and so on. It's basically always at 5 meters. So, in a distance time graph, as long as you're not moving, what you see is a horizontal flat line. Okay? Alright? So let's just go back to our textbook. If you were to go to page 27, distance time graphs. Okay, to highlight this, the first scenario is for a car at rest or any object that's at rest. You will see the distance time graph. It's actually basically a flat horizontal line. It can be horizontal at 20 meters, 10 meters, 30 meters, it doesn't matter. As long as it's horizontal, it's a car at rest. And most importantly, you must note that this is the first type of graph that we are talking about, which is a distance time graph. Okay, let's look at the second scenario. Okay, over here, let's go. Okay, over here you notice what happens to the guy. The guy is actually moving from one end to the other end, and what do you notice about his speed? Over here, he's moving at constant speed. So as long as he's moving at constant speed, you notice this line over here is it has the same gradient. Okay, it's the same amount of slope. What do I mean by gradient? Gradient simply means the amount of slope. Okay, let's just start it off again. Over here you see it's horizontal flat because it's not moving at constant speed all the way. It just stopped here, so it became flat again. Then it started again. So as long as it's moving at a constant speed, you notice this line and this line here, they actually have the same degree of slope. It's actually, or you can consider it, we call it the same gradient. Okay, so same gradient will actually tell you what speed it is. Okay, going back to our second scenario right now in our textbook on page 27, if you were to go further down, this next one is a car traveling at uniform speed. So for uniform speed, same speed, you will see, yes, the line has got a constant gradient. Okay, sorry about that, but I think I forgot to actually ask you to actually highlight this. For scenario 1, please highlight the word zero gradient. Zero gradient means it's flat horizontal. Okay, so above that, just write down these words: zero speed or not moving or at rest. Okay, that's for the first scenario. Second scenario, underline the words constant gradient and uniform speed. Okay, okay, let's go to the third scenario. Okay, third scenario over here. Okay, I think you just saw that. Okay, let's start off. What do you notice about the guy? The guy started off not moving, he's moving slowly, and oh, the speed seems to be getting a little bit faster and faster, and towards the end it's very fast, all the way to the end. Okay, you didn't catch that again? Let's show you again. Start off again, it's not moving, so you see a horizontal line. When as soon as it starts moving, you see the gradient, it starts to have a little bit of gradient, and the gradient starts to get a little bit steeper as the man actually travels faster and faster. So you notice that actually the gradient actually tells you something about the man's speed. Okay, so going to page 28. Okay, so a car traveling at increasing speed, which is a non-uniform speed, that means it's basically accelerating. Okay, the graph has an increasing gradient. So an increasing gradient graph shows that the speed is increasing for a distance time graph. Can you see the gradient here compared to the gradient here? The gradient at the end here is much steeper than here, so that's why the gradient gets increases as it goes, as time passes by. So as the gradient increases, it means that the speed is increasing, just like the simulation that I showed you earlier. So just highlight this: increasing gradient and speed increasing. Okay, so the last simulation that I just wanted to show you is this. Hope you can guess by now. We have at rest, uniform speed, increasing speed, and we started off moving pretty fast. Now it's moving slower and slower and slower. You notice this, man? So as the man moves slower and slower, what do you notice about the graph? Okay, just see again, very fast at the start, so a steep gradient. Not so steep right now, it's getting more and more gentle until it stops moving. You see right here? So as long to the end, or let me just show you the end. As long as it stops moving here, the graph here is almost flat. So do you see the gradient here? The earlier case was that it keeps increasing. Now it decreases because the man's speed actually slows down. So that brings us to our fourth scenario. So over at page 28, let's look at the part D. Okay, do highlight this. Decreasing gradient means the speed decreases. Okay, so what do we see here? Okay, so basically somewhere in the middle, this is the most important part about the distance time graph. So do highlight the word gradient of a distance time graph. Highlight this word. Tells us the speed of the object. So highlight gradient, distance time graph tells us speed. Put a star here. And the meaning of gradient, what we explained earlier, was it means the slope or the steepness of a certain graph. Okay, so that's it for distance time graph. Okay, I hope able to see the four scenarios clearly now. Okay, let's go over to speed time graphs. So our next part here will be on speed time graphs. Okay, so that brings us to the end of this part of the video. Thank you very much. We'll continue next soon.